Hello, my name is Jason Moore, and this is my Module 1 presentation. And with that, we're going to be talking about the Fibonacci sequence and its relationship to our natural world. Okay, and with that, we have a historical introduction, and it's talking about a man named Leonardo Bigelow, who resided in Pisa, Italy during the years of 1202. And he was a famous mathematician, and he did a lot of traveling through the Middle East. And upon his return, he published a book called Liber Abaci, which essentially helped progress the overall foundation behind the Fibonacci sequence. And his pseudonym quickly intertwined with the mathematical phenomenon known as the Fibonacci sequence. And once the mathematical community is aware of Bigelow's discovery, a new aspect of the Fibonacci sequence was unearthed. We have the introduction of the golden ratio into mathematics, which is a component of the Fibonacci sequence. And with that, we have three concepts behind the Fibonacci sequence, one of which is the famed number sequence that goes on as 1, 1, 2, 3, 5, 8, and so forth. And it really this repetition of numbers is really what coined Bigelow's concept. It's what eventually led to the Fibonacci sequence. And with that, you have the exponential formula that gives the Fibonacci sequence its ability to rhythmically increase as well as just double over time, essentially. And with that, you have the exponential formula, which serves as a method to accurately predict population values as well as any other as well as the progression of population as generations come and go. With that, we have numerous natural applications of the Fibonacci sequence, many of which are in the form of logarithmic spirals, and they many times include equiangular radial lines. And pretty good examples of these you can find pretty much anywhere you go, especially just doing something as simple as stepping outside of your house would be to just look at flower petals or pine cones, seashells, or any other things, as well as you can take it into a much grander scope to try to find examples of the Fibonacci sequence in nature, and especially look at the foundations of spiral galaxies as well, because they hold the same visual element of the Fibonacci sequence, which is the logarithmic spiral. In our daily life, the Fibonacci sequence really helps with specifically economics, as well as how to use the Fibonacci sequence in the fields of marketing and product dispersal. So with that, you have the Fibonacci sequence along with its inner working mathematical parts also gives light on the ways that we can calculate population growth in terms of survival, how much resources we're using, and if we have enough resources to last after a certain time frame, as well as the tracking of endangered species and their population patterns. And thank you. That was my last report.